In this video, we are going to go through vectors past papers. So we're going to get a lot of practice in this video for what we learned in the last video that was made 6 months ago, maybe. And I know I promised this video to come after, and it did come after. It just took a very long time. I'm back in uni, summer vacation is over, so I've been very busy, and I apologize for this video being so late. I don't know who actually needs this video now. I don't think any of y'all do. I don't know if y'all reached here yet, but if you did, I apologize. It's finally here. I do keep my promises. So yeah, let's get into vectors past papers. So the first past paper that we're going to go through is 2019, and we're going to look at question 4, part B, which states that the points P, Q, and R are three vertices of a parallelogram PQRS. Part 1 asks us to express the vectors PQ and QR in the form xi plus yj plus zk, which we know to be formally the unit vector form, right? So xi plus yj plus zk, where x, y, and z are the relevant entries, which means these numbers, okay? So the first thing that we're going to look at is what do they actually want? They want these vectors, PQ and QR, okay? I have no idea what happened here, but this is supposed to be like that. So we are going to look at PQ first. To find PQ, we have to get the position vectors, OQ and OP, okay? To do that, we have to find the unit vector forms, okay? So we are going to get OQ first to be, let's see what Q is, 1, 2, and minus 4. Remember that we are going to put it into a unit vector form. So we have I, J, and K. And remember the signs as well, okay? So this will be I plus 2J minus 4K. Okay, let's do the same thing for P. We have OP, the position vector, would be, let's look at P, 3 minus 1, 2. So we'll get 3I minus J plus 2K, right? And finally, for R, we'll have OR to be equal to minus I plus J minus 2K, all right? So now we're going to use these three position vectors to find what they want, which is PQ and QR. And you need to recall something that is very, very important, which is the displacement vectors, which is how we're actually going to find them. So by using the position vectors that we just found, we are going to find these vectors. So PQ would be actually equal to OQ minus OP by the displacement vector rule, okay? So now we have OQ and OP. All we have to do is subtract them. To subtract these vectors, all we have to do is subtract their corresponding components. So let's look at PQ. It would be OQ minus OP, right? So which we already found. So we're going to look at the corresponding components. We have I minus 3I, which would be minus 2I, right? Then we have plus 2J minus J. Minus and a minus is a positive. Remember that. So we'll get plus 3J minus 4K minus 2K, which would be minus 6K. Okay? And that is the vector PQ. So that is how simple it was. Now to find QR. QR, again, the same rule. It would be equal to OR minus OQ, okay? So, again, we're placing them here and we're going to subtract them. So, OR minus OQ, okay? And we're going to do this. So, we have minus I, which would be minus 2I, plus J minus 2J, which would be minus J, minus 2K minus 4K, minus and a minus is a plus, so remember that, minus 2K minus 4K, which would be minus 2K plus 4K, which would be equal to 2K. All right, so that would give us the vector QR. So we found PQ and QR, all we did, use the unit vector form, find their position vectors, plug them into the formulas that we know by the displacement vectors, and then simplify. Subtract the corresponding components. And that's all we had to do for 4 marks. All right. Now part 2 says, show that the vector S, which is minus 16j minus 8k, is perpendicular, this is the keyword, to the plane through P, Q, and R. Right? So let's get a better idea of this. We are going to look at a conceptual diagram. So we could see that PQ and QR are actually within the plane, right? So because we wish to determine the normal vector, which is the vector perpendicular to this plane, we can use the cross product, okay? I know y'all remember the cross product because it's actually the last thing that we learned in the previous video. All right, it's the last topic that we went through. So I hope that you all know how to do this. If not, we're going to go through it again. Okay, so the first thing that we're going to do is create a 3x3. So we have 3x3. We're going to start with I, J, and K. So we see that we have the component forms for PQ and QR. So we have PQ is minus 2, 3, minus 6, and QR is minus 2, minus 1, 2. Okay, so again, we're going to start I, J, and K. So let's start with PQ. We're going to put them into the corresponding forms. So we have minus 2i, this would be, so we have minus 2 under the I. This would be 3j, so we have 3 here, and then minus 6k. The same thing we do for QR. We'll have minus 2, minus 1, and 2. Okay, so that's how we begin. Then we're going to equate it to the 2x2s. All right, so we begin by doing I minus j plus k. Remember that. And then we will fill in the 2x2s. Okay, so always remember plus, minus, plus j and k. And then we do the 2x2s. Always remember that. All right. Now to know what is in the 2x2s, we have a little trick. Okay. So to know what is in the 2x2 next to I, all we're going to do is cross out the row and column that I is in, and whatever is left is the 2x2. Okay. So we cross it out, and we'll have 3 minus 1 minus 6, 2. 3 minus 1 minus 6, 2. Same thing for j. We have cross out that. We have minus 2 minus 2 minus 6, 2. Minus 2 minus 2 minus 6, 2. Okay? Then for k, cross it, and then we have this. And it's the exact same thing as this. All right? Now the big question is, how do we actually simplify these? So for a 2x2, all we have to do is know that if we have a 2x2 A, B, C, D, it is equal to A, D minus B, C. Okay? So technically, you are crossing them. So we have A, B, C, D. We multiply these two, and then we subtract them. All right? So let's do this now. 3 multiplied by 2 is 6. Minus 1 multiplied by minus 6 is also 6. So if we have 6 minus 6, that will be 0. So unfortunately, I would no longer exist in this question. Then we have minus j, and then we have AD minus BC. Remember, this is very important. This minus is extremely important, okay? So whatever you get this answer to be, remember that you also have that minus, all right? So in this case, we will get minus 16, I believe. And then because of that minus j, we would get 16j, positive, all right? So then for k, let's look at this. So this would be 2 minus minus 6. Okay, so 2 minus minus 6 will be 8. So we'll have 8k. So our final, by using the cross product, would be 16j plus 8k. All right. So we know that any scalar multiple of 16j plus 8k would be a normal vector to the plane. Okay, so let's say that we see lambda. Okay, lambda, yes, lambda. Lambda multiplied by 16j plus 8k is a normal vector to the plane, which means perpendicular, right? Where lambda is literally any real number. So in this case, we'll say it's -1. You can let it be any you would like. And then we'll have, but just for simplicity, you know what I mean? Just to be as easy as possible, we will get -16j minus 8k would be perpendicular to the plane passing through P, Q, and R, which is exactly what they asked us for. Okay, so that's how we do part 2. Part 3 says, hence, determine the Cartesian equation of the plane through P, Q, and R. And this is for 4 marks. Okay, so because we are not given any information about the distance from the origin, we have to choose an appropriate equation. Okay, so we would choose r dot n is equal to a dot n, where remember r is just that vector. Okay, so we have r to be x. What kind of x is that? X, y, and z. All right. Then we have n, which would be the normal vector to the plane, which is actually what we know, which is the vector perpendicular to the plane. A would be a point on that plane, and we already know that n is also a normal vector, okay? So n we found to be 0, minus 16, minus 8 from our previous question. We found that. R would just be x, y, and z, and we're going to use any point. So we're going to use P, all right? So let's just use P from a question given above. Okay? All we're doing now is simplifying. So remember that we're doing the scalar product and using that property to simplify. So when we do that, we will end up with -2 is equal to z. Remember, this is very simple. However, if you mix up the math just a little bit and the signs, that's where you could go wrong. So do this not very slowly, but take your time while doing it and make sure to check over your work. So you'll know that the Cartesian equation of the plane through P, Q, and R is -2y is equal to z. Now we're going to go through 2021 question 4, part C and D. So for 8 marks, part C says, 2 position vectors are represented by OA and OB in their forms. Okay? Determine the angle between OA and OB. So all you need to do for 8 marks is apply one formula and do the calculations correctly. This formula just happens to be very, very complicated. Okay? So remember that the formula for the angle between 2 vectors is as such. We have the product here, the dot product here, and then we have the magnitude. And this is very, very simple. Okay? These in itself are very, very simple. However, when you have to put them all together, this is where the problem occurs. Okay? So because it is 8 marks, I highly suggest you take your time to do this. All right? So you put them apart. So you do this first, then you do this, then you do this, and then you put them back together. Okay? So we substitute them, we substitute everything, and then again, right? Take your time to do the math. We know how to do it. This is how you do this. So you basically just put in everything into these formulas to do it. And also your calculator. I really hope that they allow, I assume they're still allowing that Casio calculator. You can do these trees on the calculator just to check, right? However, they will want to see you working to get the full marks. So make sure to do that. The answer for this one, and you are going to be able to do this at home and make sure you get theta to be 85.9 degrees. Okay? So again, all we did here was simplify the top. Then I did the magnitude and the magnitude. To get this, remember, when a square root of the same number is multiplied by each other, the square root is removed, right? So you'll get 1/14. Then you plug in this in the calculator, and then we'll get 85.9 degrees. So I want you to do all the manual work and make sure you get this as the answer. All right. Now part D says to determine the vector equation, so the vector equation of a plane which passes through this point and is perpendicular to the vector 4i plus 4j minus k. So we're given the point on a plane and the normal vector, which is 4i plus 4j minus k. So we have to recall the equation of the plane, which should be r dot n is equal to a dot n, where this is the normal vector and this is the point. Okay, so now all we have to do now is just substitute. So we're going to use the property of the scalar product here to solve for this. So we'll have 2, 4 plus 5 multiplied by 4 plus 3 multiplied by minus 1. So we'll have 8 plus, was 5 by 4? 20 minus 3. So we have 28 minus 3, which would be equal to 25. We have 25 here. That's all we did here. And then we can see that this is the vector equation. And for 4 marks, it was that simple. Now we're moving on to 2022. And you're going to see some similarities already. So let's do question 4, part B, part 1. And it states, determine the equation of the plane that passes through the point 0, 2, minus 2, and which is perpendicular to the vector v, which is 3i plus 2j plus 4k. And this is for 3 marks. Okay, so we already know that we are given a point and a vector perpendicular, okay, which is the normal vector. Remember, perpendicular and normal, same thing. All right, when we're given these two things, we know we have to use r dot n. R dot n is equal to a dot n. A is the point, and this n is the normal vector. Okay, so let's substitute. We have r dot n is equal to a, which is the point, dot n. So these are the same. Then we are going to start simplifying. Let's simplify the right hand side. So this is equal to 0, 3 plus 2 by 2 plus minus 2 by 4, which is 0 plus 4 plus minus 8, which would be equal to minus 4. So we have minus 4. This is the vector equation of the plane. And let's go into the Cartesian equation. All we do is get the x, y, and z. This is r. Remember, r is equal to x, y, and z. And then we simplify to get the Cartesian equation of the plane. All right. Now for part 2, let's determine the angle between the vector 3i minus 2j and x-axis. So what is the x-axis? This would be x, O. Okay, so the x-axis can be written as a vector xo. Okay, hence we have two vectors, 3 minus 2 and xo. Remember, the same thing. It's only 3 marks, but it takes math. Okay, this is a lot simpler than when you have 3 components though, the x, y, and z. Now you only have x and y. All right, so we're using the same formula. And this will be a lot simpler. Remember to use the product and the magnitude. However, you will not have A3 and B3 or A3 this time. Okay? So it will be a much simpler. And I want you to make sure to do it at home. Don't just look at the video. I want you to do it right now and make sure you get 33.7 degrees. Okay? And let's move on to part C, which states, the parametric equations of a line are given as x is this, y is this, and z is this. So it says determine the coordinates of the point where the line crosses the xy plane. Remember, the xy plane. Okay? So let's start. We're given the parametric equations. We'll write them out. Remember when I said I emphasize xy plane? This means that z is equal to 0. Okay? So if z is equal to 0, we can get the value for lambda. When we substitute in the value that we found, which in this case is 2, into x and y, we get 12 and 5. Okay? Therefore, the coordinates of the point where the line crosses the xy plane would be 12, 5, and remember, this would be 0. Okay, so it was that simple. And that's 5 marks right there. Now we're moving on to 2023, question 4, part C and D. Part C, part 1. Again, notice the similarities. Determine the vector equation of the plane which passes through this point and the vector perpendicular. Okay, so again, r dot n is equal to a dot n. Let's do it. We have the scalar, so we solve in using the scalar product. We get 19, and then we get the vector equation of the plane. So let's not stress too much on that because we've done that a million times over. You, however, make sure you do it at home. Part 2, hence determine the coordinates of the point in the plane where y is 3 and z is 1. So we're recalling this, which we found. We're letting r is equal to x, y, and z. When we do that, we simplify. So when y is 3 and z is 1, we get x to be 2. And then, again, so simple. Hence, the coordinate would be 2, 3, 1. Okay, so all we did again was from the last thing that we got, we are using r to be, which is what it is equal to, by the way. This is just us writing it out. X, Y, Z. Finding that equation and then using the points that they gave us, okay, to get the actual coordinates of the point. All right, so the final part is part D. So part D says, given that a line is parallel to the vector u and the vector v is normal to the plane, calculate the angle between the line and the plane. All right, so let's look at this as illustration. All right, we have the line and the plane, and we want to find this angle. Okay, so what we're going to do is try to find this angle first between the line and the normal to the plane, and then adjust to find the angle between the line and the plane. All right, so we're finding this. Oh my goodness. So we find in alpha. However, we're going to use theta to be able to find alpha. So when we find theta, we are going to use this understanding, what we found from this illustration, to be able to find that angle that we want, which is alpha, between that line and the plane. All right, so let's do it. To be able to find the angle between two vectors, we know this formula, and we know it very well. Again, we also know that we have to be very careful when we're doing this, as it takes a lot of time and effort. So we do it, and I want you all to make sure to do it and check to see if you all got 119.5 degrees. Now that we have theta, we are going to use it to find alpha, which is actually what we are looking for. So from the diagram, we see that theta is actually equal to 90 degrees plus alpha. So we could find alpha given we have the value for theta. So alpha would actually be equal to 119.5 degrees minus 90 degrees, and that is equal to 29.5 degrees, and that is our answer for part D. So please make sure to practice and do as many questions as you can, because it is crucial for you to be able to make sure that you understand everything.